Mrs. Shomana Gracia Jacob, ME in Computer Science, lecturer in CIPAT, Chennai for the past 3 years. She has published 4 national and international papers. She has won Star Achiever Award for academic proficiency.
Welcome to the UGC lecture series in computer science. In today's session, we will be seeing about the concept of overloading in C++. Overloading relates to polymorphism that we have already learned in object oriented programming. Polymorphism refers to a function or an operator performing or exhibiting several forms. So, the implementation of polymorphism is done using this function overloading and operator overloading in C++. In today's session, we will be seeing about this overloading concept. Overloading is making an object, a function or a class performing more work than what is actually expected of it. Generally in C++ we overload only functions and operators. So, we will see how function overloading and operator overloading is implemented in this software programming paradigm. Function overloading is defined as the process of using the same name for 2 or more functions. So, one function exhibits different forms because we are giving it the same name. Name is actually an identity for a function. So, when there is more than one function with the same name, we have to identify that function stating that there are several functions having the same name. So, how to differentiate between the two? So, that same name function is doing more jobs than it is expected to do. That is why it is called overloading. And each redefinition of the function, that is a function has the same name. So, when it is being defined again and again, so when there are 2 functions you will have 2 definitions, 3 functions 3 definitions. So, how are we going to differentiate between these? It is done using the type of parameters. The functions will be different in the data type of the arguments that they hold or the number of parameters. One function will have only one argument, another function can have 2 or 3, or in the sequence in which the parameters are arranged in the function. So, though the functions have the same name, based on the parameters that they carry, either they will be different in the data type, different in number or different in the sequence of arrangement. The number type or sequence of parameters in a function is only called the function signature. So, signature is something that identifies a person. Similarly, signature of a function identifies the function. So, the difference in the functions, though they have the same name, is called the function signature. We will see an example for function overloading. Here you have the class which is called over. You have 2 functions defined under the public section, that means they are visible to all the other objects and classes and functions. One function is having an integer type value to be returned. The name of the function is max. It is carrying 2 integer variables int and int. The next function returns a float value. The name of this function is also max, but if you see it is having 2 arguments of type float. So, though both the functions are having the same name max and max, the number of arguments are same, but the data type of their arguments are different. Like one function is having an integer argument, the other is having float. So, here the functions are defined, the class gets over there itself, but you are defining the function outside the class using the scope resolution operator, which we have already seen in the previous session. So, using the class name and the 2 semicolons, 2 colons one after the other called the scope resolution operator, the name of the function and the variables they carry. You are opening the function here using the flat brace, and here you are trying to find out of 2 numbers which number is the maximum. So, if n1 and n2 are the 2 numbers which are passed to this function, you are checking whether n1 is greater than n2. If n1 is greater, you are returning the value n1, and if n2 is greater, you are giving the else statement and returning the value n2. This is for the integer function. Next, you are closing the function definition over here. Next, you are having the second function with the same name max, which is having a float return type, again the class name, scope resolution operator, the name of the function max and the arguments. In this again you are checking whether n1 is greater, if so you are returning the value of n1, and if n2 is greater you are returning the value of n2. So, with this the creation of the class part is over. So, the name of the class is over, it is having only public member functions, they are having the same name max. So, that is only called function overloading. One function max is carrying integer arguments, the other function max is carrying float arguments. So, both the functions are doing the work of determining of the two numbers which are sent to it, which number is greater. So, using the main function, how we are going to make use of these overloaded function max. So, you see max and max are having the same function name. We all know that the execution of a C++ program starts from the main function. So, in main you are creating first the object for the class, because every function can be accessed only using the object of the class, and the syntax for creating the object is class name followed by object name. So, here the object name is O1, and then directly you are using the cout function where you are calling this function max. So, using the object O1 dot max, we have already seen that the dot is the member access operator. To access the member of a class or the member function of a class, you should use this dot operator. So, using the object O1, you are accessing the function max. So, now of which of the two functions, which particular function will be called, that depends upon these arguments. So, here if you see you are having two arguments 3.1 and 4.5. We all know that when there is a decimal value, it is a float, it means a float value in C++. So, immediately the control will go to the max function which is carrying the float values. So, we will see which is the max function carrying the float values. This max function is carrying the float values. So, the 3.1 and 4.5 will get back to this max function float n1 and float n2. So, instead of this n1 it will be 3.1 and instead of this n2 it will be 4.5. Then it will check the values over here, whether n1 is greater than n2 it will return n1, otherwise it will return n2. So, this is how the max function is identified among the two other functions. Now, if you see the next function call, here again you are having a cout function, here you are having O1 dot max again, but the values which are passed here are integer values 10 and 5, there is no decimal. So, when this particular parameter is seen by the compiler, immediately it will see which of the two max functions have to be called. The first function is having integer values, the second is having float. So, because they are passing integer arguments of 10 and 5, it will immediately switch control to this max function, and again it will execute the same set of statements. If 10 is greater than 5, return 10, otherwise return 5. So, we know that 10 is greater than 5, so immediately the result that will be returned to the function is 10. So, cout statement will first display 10. So, the cout statement here will first display 4.5 and the next cout statement will display the value 10. So, this is how, though the functions have the same name, based on the arguments which are passed to the function, it will compare the data type of the arguments, the number of the arguments, the sequence in which the arguments are arranged of the functions which are defined, and according to the arguments which are passed, it will execute that particular function and it will return the result back to the main function. That is why in both these functions there was a return type integer and float. Integer function will return only integer type values, float function will return float type values. Now, we should be very careful when we are passing the arguments over here. Now, suppose here instead of you have just given 10 and 5.5, in that case the compiler will get confused because there is no such declaration of a function. Either you have two float values and two integer values. Now, if you are going to pass one integer and one float value over here, the compiler will not accept it, there will be an error because there is no such function called max. So, when we are overloading a function, the programmer should be extremely careful that he should be aware of how the functions are overloaded and how the functions differ, and according to that he should call those functions. If the functions are declared in a different way and you call the functions in a different way, the compiler will not be able to execute your program. So, that is a point to be kept in mind when we are overloading these functions. Next, we come to function signature, the definition of which we have already seen. They differ in the number of parameters in the function. So, this is an example. Here if you see, there are two functions, one is void add having one float argument and one integer argument. The other is also a function add which is having only one argument float. So, here in the number of arguments itself the two functions differ, though they have the same name. The next type of difference if you see is the data type of the parameters. Here again there are two functions with the name DISP, which is a short form for display. The first function is having the character data type, the second function is having float. Next you have the order of the data types of the parameters, the orders in which they are arranged. Here again the two functions have the same name disp, they have the same number of arguments, and if you see both the arguments are of the same type, but the order in which they are arranged is different. The first function is having first character value and then float value. The next function is having first float value and then character value. So, these are the different ways in which you can reorder the you can change the redefinition of the function. This is the way you can have the functions with same name and have the difference in their signature. Next we move over to constructor overloading. We have already seen what are constructors. Constructors are special types of functions in a class or special type of member functions that have the same name as the class name, and they are used only for initialization purpose. So, these types of functions can also be overloaded in C++. We will see an example for that. Here again you are having a class, the name of the class is CAL, it is a short form for calculate. Here you are having private members, data members of integer type, 3 variables you are having n1, n2 and TOT. TOT is a short form for total. So, from this itself you can identify that you are trying to calculate the sum of 2 integer numbers. Then you are having the public part of the class. Here if you see there are 2 constructors, one constructor is cal with no arguments, the other constructor is also cal with 2 integer arguments. Then you are having get member function with 2 integer arguments again, you are having an add function and you are having a display function. So, the first n1, n2 and tot are called the data members. You have the class ending after disp with the flower brace ending with a semicolon. Get, add and disp are called member functions. Cal, because it is having the same name as the class, they are called constructors. So, this is the organization of the class. You are having the data members, you are having 2 constructors with a class name and you are having 3 member functions. So, now we have to give the definition. Here we have only declared what the class holds. Now, we have to identify or define what each function and what each constructor is going to do. So, here you have the first constructor function using the class name, the scope resolution operator, you are defining this constructor with no arguments. You are initializing the data members to 0. We all know constructor does only this work. And then you are closing the first constructor function. Then you have the next constructor function which is having 2 integer arguments. Here what you are doing is whatever arguments are coming out in this constructor function, that you are assigning it to the data members. So, it is not necessary that in a function you need to initialize the values only to 0. A constructor with no arguments initializes the data members to 0, but when you want the user to define his or her own values and initialize the data members, you go in for this concept of constructors with parameters. This also we have seen in the previous session. So, here these values will be given by the user and these values will be given as the initial values to the data members of the class. But we should always remember that when we are using a constructor, every data member of the class should be initialized. Here if you see you are having only 2 arguments, you are initializing that to n1 and n2, but this third data member tot has no value over here. So, you are simply initializing it to 0. So, these are the definition of the constructors. We will see the member functions after the break. Welcome back after the break. So, we have been seeing about constructor overloading before the break session. We had seen the definition of the constructors. Next we will move over to the definition of the member functions. We have 3 member functions here: get, summing up and displaying of the result. So, here we are having the constructor overloading which we have seen. Now, we are going to see the definition of the member function get. So, in get again you are having 2 arguments. Again you are initializing the 2 arguments and giving them as a result to n1 and n2. Now, you can very well see the difference between these 2 functions. Here also you are having initialization, here also you are having initialization, but here if you see this third member tot is also initialized, here that is not there. This is because the work of the get function is not initialization. You can do anything in a get function. You can get the value from the user, or you can simply initialize the values to 0 or to any other argument, whereas in a constructor initialization is the only function. That is the reason we have to initialize all the data members of a class in a constructor function, whereas in a user defined function whatever values we need according to the program's purpose we can initialize the values. So, in this get function, because it is a user defined member function, we are initializing only the integer values which are required at the moment, and the get function is closed. Next we have to define the add function. Add, we all know it is to sum up. So, n1 and n2 are added, the values given to TOT, and then display is to display the result. So, see out, the sum is TOT. So, with this all the definitions of the functions are also over. So, the class has been fully created and it is now complete. Now, the program execution will begin from the main function. So, here we have the definition of the main function. Inside the main function, to access the data members and member functions we need the object. So, first we have to create the objects for the class. Now, first when you are creating the object, cal C1. So, C1 is the first object. As soon as the object is created, we know that the constructor function is called. So, now there are two constructors in this program. Which constructor function will be called? Now, the compiler will next see the parameters of the constructor. One constructor is not having any arguments, the other constructor is having two arguments. So, when the first object is created, when the C1 is created, the compiler identifies that it is not carrying any constructor or it is not carrying any arguments. So, immediately the compiler will move to the constructor functions with no argument. So, it will initialize the values of n1, n2 and TOT to 0. When the next object is created, C2, 10 and 20, immediately the compiler will move to this constructor. It is having two arguments 10 and 20. So, it will assign the value of 10 to D1, 20 to D2, 10 will be assigned to N1, 20 will be assigned to N2, and TOT will be initialized to 0. So, these are the two things done by the compiler when it sees the first two objects being created. The next, the compiler creates a pointer variable. We will see how this is used. Cal is a class name, pointer PT. Now, here if you see, PT is equal to new cal of 23 comma 13. Now, this 23 comma 13 comes again with the constructor CAL. That means you have to call the constructor which is having two arguments. But how is this pointer variable going to call that function or call that constructor? For that reason, we have here a new definition called new operator. We will see the definition of this new operator before we proceed to the calling of the cal function. Now, after that we are having C2.add and C2.disp, which is nothing but using the object you are calling the two functions. Then you are having PT member access operator, that is this arrow mark operator, add and disp, and then you are having this delete PT. So, why is this new operator used and why is this delete operator used? Only with the pointer variable. So, they have a special purpose in C++. So, we will see how these delete and new operators work over here. This delete and new operator are used with dynamic memory allocation. This we have already seen in C, where we have the malloc, calloc and realloc functions, where at the time of programming only or during the time of execution only, the compiler will allocate the memory according to the variables that are needed for execution at that particular time. So, it is a waste if we are going to allocate memory for variables which are not going to be used during the program. Memory is a very it's not a resource that is just going to keep increasing. It is well within defined boundaries. So, we have to use the memory very efficiently. So, that is the reason we go in for this new and delete operator in C++. New operator allocates memory, delete operator frees the memory. So, how are we going to use these operators? When we request for dynamic memory, the new operator is used, and this is the syntax. The pointer variable is equal to new keyword and the data type, or pointer variable new keyword and the number of elements. So, this is an example for that. Integer is the pointer variable, integer pointer p is the pointer, is equal to new, int is the data type and the number of elements. So, how is this going to be put in memory? You have the p variable pointing to the first block of the 5 number of elements that have been allocated. So, this is how it will be identified, new int of 5. So, you have 5 blocks of memory over here, 1, 2, 3, 4, 5. P is the integer variable and that points to the first block of that set of memory. So, this is how the new operator allocates memory in C++. Next we move over to the delete operator. Now, as I have already mentioned, dynamic memory is very much limited, so it has to be efficiently used. When it is no longer needed, the memory needs to be freed, and to free the memory only we use this delete operator. The syntax is very simple: delete pointer, either just one pointer variable if it is there, and if that it is an array of pointers, we have to use the square brackets to represent the array. Now, the value which is passed is an argument to delete. Now, see, when you say delete, you should tell which memory has to be deleted or which pointer has to be deleted. The example programs that we are seeing have only one or two pointer variables, so we just give delete and the pointer variable name. In big programming methodologies, we may have several pointer variables. So, when you give delete, you should specifically mention which pointer is to be deleted. So, there has to be an argument to the delete operator. The argument must either be a pointer to a memory block which is previously allocated with a, so that pointer should have been allocated by the new operator. It cannot just be any pointer, only when memory has been dynamically allocated, it can be dynamically released. Or it should be a null pointer. Null pointer indicates that there is no memory existing there because no memory was allocated. It is not necessary that when you give new, immediately the memory should be allocated. You do not know whether memory is available or not, because the program is just executing. So, the programmer does not have any idea of whether when he gave a new operator to allocate memory, whether memory was allocated or not, because memory is very less in number. We are giving new because we want the memory, but whether the computer is having the memory to give us or not, we are not aware. So, if new operator had failed in its execution, it will return a null pointer. If it had succeeded in its execution, it will have the pointer to a memory block. So, when we give the delete operator, it should either be a pointer to a block of memory previously allocated, or it should be a null pointer. If it is a null pointer, the compiler will understand that the new operator's execution did not succeed. So, it does not have any memory to free at the moment. So, the programmer needs to check whether the requested dynamic memory was allocated or not. He cannot take for granted that when new is given, memory is allocated. So, what happens if new does not succeed? One is the concept of exception handling, which is a separate concept in C++, which we will be seeing later. The other is called the no throw method. No throw method is, in case the memory allocation fails, the pointer returned by the new is null pointer, and the program will just continue its execution. It will not affect the proceeding of the program in any way. See, we want a program to be like that. Just because new operator fails does not mean the entire program should crash. So, we want the compiler itself to make certain alternate arrangements in case the memory is not allocated. So, that is only done using this no throw method in C++. So, that is a use of this new and delete operator. So, when new is used over here, that means memory is allocated for this pointer variable pt, and immediately the constructor with two arguments is called. So, 23 will be allocated to the first number, 13 will be allocated to the second number. And in the next statement, what we are doing is using the C2 object, we are calling the add function. So, what happens when the add function is called? The compiler will go to this add function, it will add the two numbers n1 and n2, and it will assign it to tot. So, the n1 and n2, so tot will be carrying the result of the added sum. Next, C2.disp, it will display the result. Then this is a pointer variable. We know that when we use a pointer variable, we cannot have the dot operator. We have this arrow operator to access the members of the class. So, using this pointer variable, we are going to give pointer.add pointer disp. So, this add function is going to add these two variables 23 and 13, and the display function will get the result. Now, we will see the output. The output is all in this display function. So, C2.disp and pt arrow mark disp. So, this disp is going to display the added sum. In the case of C2, the numbers are 10 and 20. In the case of pt, the numbers are 23 and 13. So, the first result should be 30 and the next result should be 36. So, whether the result is correct, the sum is 30 and the sum is 36. So, this is how the pointer variable and a normal object can be used to access the members of a function. So, we have seen constructor overloading, constructor with no parameters, with two parameters, and an object which is a pointer variable, how it is accessing the member functions of a class. and how the compiler tries to differentiate between the constructors and the member functions, and how to access the member functions if we are having a pointer variable. And when we use a pointer variable, we have to allocate memory using the new and the delete operator. Here if you see, after the pointer variable's work is over, immediately we are giving delete pt. So these are the different types in which a normal function and a constructor function will be overloaded. Next, we just have an introduction into this concept of operator overloading. This is nothing but providing additional meaning to C++ operators. Only predefined set of the C++, or not all operators can be overloaded. An operator, if it has to be overloaded, again we have to define a function for it, what the operator has to do, that has to be told. And the function is always declared using the operator keyword. So we need to know what are the operators that should not be overloaded, the rest can be overloaded. We have to define the function for it, and that has to be done using the keyword operator. So these are the functions that cannot be overloaded: the member access, the pointer to a member or the indirection operator, scope resolution operator, conditional ternary operator, and the size of operator. The logical AND, logical OR, and the comma operator. These all operators cannot be overloaded in C++. And in operators also, they are considered as functions internal to the computer, because an operator is already having a predefined function. Plus, minus, multiplication and all, they have functions of adding, subtracting, multiplying. So if we are going to define a function, that has to be user defined, different from the function that is already known to the compiler. So functions that perform this additional task, when they are doing more work than what they are expected to do, they are called operator functions. And they have this syntax: return type, class name, scope resolution operator, this operator keyword. Now this is what is new, this operator keyword is new, this operator symbol is new, and this parameters is new. So this is what is different in the operator function overloading. The rest of them, return type, class name, scope resolution operator, all this comes with any function definition. So in overloading, we have unary operator and binary operator overloading. We will just have an introduction into these unary operators. The function operator has to be associated with a class. If a function is defined inside a class, you do not require any arguments like this. The function will look like this: object.operator and only the symbol. It does not have any arguments. If the function is global in nature, then you need an object of the class as a parameter, and that is how you associate it with a class, and the example is this. So in between these two functions, if you see, the operator is the same, the symbol is the same, only thing here you have an object as a parameter, and here you are not having any arguments. So this is the over class having two integer members. You are having three functions over here. This is only called the operator function, this is a member function, this is the display function. So you are just accepting a value and you are displaying it, that is all. So these are the definitions of the functions. You are having the operator function with the symbol, no arguments, that means it is defined inside the class. So when you are giving just one operator, you know the work of the minus operator, it is to change the sign of the variables. So a is equal to minus a and b is equal to minus b. Then using accept, you are accepting two values, p you are assigning to a and q you are assigning to b, and display, we all know it is to display the result a and b, that is it. So using the operator minus, you are changing the sign, using accept you are getting the values from the user, using display you are displaying the values. So how is it accessed from the main function? Here you are having the object creation O1, O1 dot accept. So in accept, what are you passing? Minus 45 and 18. So as soon as the compiler sees this particular function, it will go to this accept function, it will give minus 45 over here and it will give 18 over here. Then O1 dot disp, that means first minus 45 and 18 will be displayed. Then you are calling this operator function minus O1. So as soon as this minus O1 is seen, the compiler will go to this function. It will make a is equal to minus a, b is equal to minus b. That means the signs are reversed, and then O1 dot disp. So the output will be first minus 45, then 18, then plus 45 and minus 18. So this is how an operator function is defined. You are making it change the sign by clearly defining a function for it. See, this is just a simple program where you are trying to say how a function is defined and what it is doing. It is not necessary that you have to have only that particular function in that operator function. Apart from changing the sign, you can make it add or you can make it subtract, it is a user defined function. You are defining the work for that operator. I am giving a simple example only because you should be more familiar with the syntax and understand how the compiler is calling that particular function. So, in operator overloading we still have to see unary operators and postfix, prefix operators and binary operators. So, that will make you more familiar with the concept of operator overloading. So, in today's session we have seen about the details of function overloading, an introduction into operator overloading and how to overload unary operators and the new and delete operators. The possible questions in the session are the function signature and how functions are overloaded. That is, here you have to talk about the function signature. The advantages of function overloading is you do not have to remember many function names. Just using one function you can perform a number of operations. Operator overloading is making an operator do more work, and significance of new and delete operator. So, in this session we have seen about function overloading, operator overloading and certain operators, methods in C++. We will see the rest of operator overloading in the next session. Thank you.